this short video, I'd like to talk you through how to complete a combustion analysis type problem in the Open OChem homework. You can see that I've scaffolded the steps, which hopefully you find useful to remind you what are the steps in the combustion analysis, but there are many spots to input answers, and of course if one answer is incorrect, well then you don't get the full points, and you may get a little bit frustrated. So I want to show you with the very same question that's found in your homework, how to complete this. Of course, you will get a similar sort of question in the quiz, and of course, if you don't quite get it right, or if the platform doesn't recognize your correct answer, I can always correct it after the fact. If you email me, I'll take a look. Now, the goal of showing you this, however, is not necessarily to teach you how to do a combustion analysis problem. I show you how to do that in the Chem Activity 7 addendum, but rather it's to show you how to apply what you learned from watching that video to the Open OChem homework system. So we have a compound, its mass is 3.432. It contains only carbon, hydrogen, oxygen, which is fairly typical. Sometimes you only have carbon and hydrogen. Sometimes you have sulfur instead of oxygen. The approach is very similar in all of these cases. Inevitably, we, in this combustion, will be producing carbon dioxide and water. We use the mass of carbon dioxide to tell us about the mass of carbon in the compound. We use the mass of water to determine about the mass of hydrogen. Once we know the mass of carbon and hydrogen, and we know the total mass of our sample of compound, we can then determine the mass of oxygen, and then after that, it's very easy to determine the empirical and the molecular formula. So the first table chart here is the initial combustion analysis. So we need the mass of our product, CO2, and like I showed you in a previous video, sometimes you can just cut and paste the information that's already given. So that's the mass of our CO2 product. We're going to calculate, and I give you the formula here, we're going to calculate the amount of CO2. We'll use the 1-to-1 ratio of carbon, 1 mole of carbon to 1 mole of CO2 to find the mole of carbon, and then we'll multiply that by the molar mass of carbon, and that will give us the mass of carbon in our compound. So this comes to 1.373 grams. So that's the mass of our carbon. I applied a similar strategy to find the mass of hydrogen. Be careful, it's always 2 mole of H per 1 mole of H2O. Now, because I have the mass of carbon and hydrogen, I can find the mass of oxygen. So I start with this 3.432 grams of our compound. I'm going to subtract the mass of our carbon. So you'll see that we often we repeat the values. So hopefully we get them right in the first stage. Okay, I'm going to now do the subtraction. And in doing the subtraction, I find the mass of the oxygen, which turns out to be 1.828. Okay. So, as a check, of course, it should be that when we add up the mass of oxygen, the mass of hydrogen, the mass of carbon, it should give us the mass of the compound. I also try to guide you a little bit in thinking about the sig figs. So all of these numbers have 4 sig figs. In the case of hydrogen, that led to 4 digits past the decimal place. Of course, when we do this particular subtraction, what's going to determine the number of sig figs is the fact that the compound and carbon each have 3 digits past the decimal place. So my oxygen will have 3 digits past the decimal place, 4 sig figs. So now, mass of our carbon, which will be 1.373 grams, our mass of oxygen, which will be 1.828. So when you're doing this, maybe try not to rush too much. It's very easy to put the wrong number in. I know because I have kind of rushing through and I just picked the wrong number. All right, so this bottom chart is really similar to, or essentially the same thing, when we're doing a typical empirical formula analysis and we find the mass of each element in the compound, we then convert to the amount. So we're going to divide by the molar mass of carbon, divide by the molar mass of oxygen. So the amount of carbon that's present to 4 sig figs is 0.1143. And in fact, the amount of oxygen is also that same number, so 0.1143. Now we want to find the mole ratio. So essentially, we can divide by 0.1143 for any of these amounts, and indeed, we'll come to 1.00. And I tell you that I want 4 sig figs because the idea is that when you initially find the mole ratio, you really don't want to round off until you're certain that you know what's going on here, that it's not 1.33 or 1.5 or 1.25, but indeed it's going to be 1, 2, 1. So of course this is representative of the empirical formula. So 1, 2, 1. And now I want to take this information and find the molecular formula. I know the nominal mass is 60 grams per mole. Again, I'm trying to highlight about sig figs. So this is 2 digits. It's only 1 sig fig. If I calculate the empirical formula mass, so the mass of 1 mole of carbon, the mass plus the mass of 2 mole of hydrogen plus the mass of 1 mole of oxygen, I will get 30 grams per mole. So clearly the ratio is 2 here. And therefore the molecular formula will be 2 and 4 and 2. And with some luck, when I submit, I get the correct answer. Okay, so please follow these steps. Get the correct answer in your homework, but then be prepared to follow these steps when you actually do the quiz. I hope you have found this video to be of benefit.